All right. So, welcome everybody. This is the June edition of the Tampa Salesforce Architect Group community meeting. Glad to have everybody here. Today, we're lucky enough to have esteemed CTA Poonam Keswani. Hopefully, I didn't slaughter your name too bad.
That was quite close.
And
All right.
we'll let Poonam describe what she's going to talk to us about, and we'll take it from there. So, I'm going to hand the
Sure.
screen over to you.
Thank you. Thank you, Walter. I hope you guys are able to hear me okay.
I can hear you.
Great. All right. Hello, everyone. Um, I'm Poonam Keswani, a Salesforce CTA and a senior manager with Accenture. Today, I'll be talking about and simplifying these different Salesforce integration patterns. We'll also talk in detail a bit about what is the right way or what is the preferred or the best way to implement these integration patterns on your Salesforce platform. We will also touch base on probably I should go to the agenda. Um, Different factors that affect selecting the correct integration pattern. We'll deep dive into different integration patterns, and then we'll do a quick decision matrix of which integration pattern to pick in which situation. Followed by we can have some Q&A, and depending on the time that we have. So let's move on. Hopefully, we can pause to ask if you have any questions. Feel free to pause and ask them. All right. So just a key introduction of what is integration. So you cannot run any business completely on a single platform. You have to have some amount of transactions at different layers for you to be able to run an end-to-end business process. This could make your entire requirement slightly complicated if you bring everything on platform. So always be mindful of what is the capability of the system that you are interacting with, and use that system well and integrate with that system well. Now, when we talk about integration, there are two different, I mean, there is a terminology that we use that if and if Salesforce is calling any external system, then we call that as an outbound integration. Now, in a situation where some system is calling into Salesforce, that's an inbound integration. I'll be using these terms very a lot in the next 1 hour, and whenever you interact with your fellow technical architects or business, or your probably your developers, these are the terminologies that you should prefer to use, and be able to communicate the message. So yeah, we spoke about outbound integration. That is when Salesforce is calling an external system, and then inbound integration where an external system is calling into Salesforce. Uh, Now these integrations that we have, you could primarily classify them into three different type of integration. So that is data layer. When you are integrating at a data layer, that becomes a data integration. When you're integrating for an end-to-end process where you have, when you call in into a certain system and you get a response, you parse and show that to the user, that's a process level integration. And the third part is a virtual integration, which in which your data is not residing on your platform or any other system. However, you are still virtualizing or bringing that information from the other system and showing it on your platform. Now, whatever we talk about integration, it's a very it's not something which is specific to only Salesforce platform. It is a very architecture concept, and hence all this can apply to uh, your different projects or your different interaction with different teams as well. Now, if I take a simple example of placing an order, say from any system, right? There are different aspects within that one interaction that we are talking about. So when you want to place an order, what do you see? You see a list of products. You see a list of a price associated with that product. Now, where do you think that data comes from? That may not be. It may come from any some other master data, right? So that's your data layer of integration, where your master data, which could be an SAP or any other like a PIM system, is feeding that information on your platform or onto your system. So that is a data layer of integration. Now, when a user tries to place that order and make a payment, that's a process, right? You validate the price, you provide the credit card information, you make that payment. That's a process that goes through. That's a process layer integration. Now, After this, say your order is placed, it goes to fulfillment, and then now the user wants or the customer wants to find the status from a fulfillment system. Now that's virtualization, where you don't want to bring the information from the fulfillment system onto your platform, but you want to still show the status of the order to your user from the fulfillment system, and that becomes your virtualization, where you are not storing that information on your platform, but you're virtualizing or showing that status from some other system. Now, when you do all these type of integration, there are different factors that come into selection of a certain pattern, right? We will talk about all these five patterns in detail. Now, the key factors that determine the kind of pattern that you need to use for the type of integration that we saw is whether do you need to have it real time or can it wait. For example, a data layer of integration can wait. It can happen, say, overnight to sync up the product or catalog information, right? But if it is a payment information, the user will expect to get response right away. So you need to understand whether is it business critical to get the response of whatever is being processed. What is the message size? Ultimately, you have to understand integrations happen between two different systems. You're going over the network, so you need to understand the size of the message as well. Now, is a guarantee of a delivery needed? Like, does the external system need to confirm that the order or the integration was completed or not? What happens if the external system is down, right? All these are the other considerations that you have to make. Other thing is when two systems are interacting, there should be a contract which has been established between both the systems. So there a possibility that the contract is established before or not? These are, and the last is whether is there a preference to go with declarative, right? We work on a platform where time to market is always very critical. So do you and integrating systems is not easy. Now, is there a declarative approach that is preferred? Is the other question that you would ask. Now, let's go and deep dive a bit into why do we need these integration patterns, right? Because these are in complex situations, you need to understand, you need to break down the process, and you also need to in the world of cloud computing, you also need to use your resources effectively, right? For something, for example, like I spoke about the product and pricing. Now, you wouldn't go to show your user the list of products every time. You cannot make that integration call out. You are working in a multi-tenant environment where your resources are shared. You have to be cognizant of the fact that you are using the resources correctly, and hence the correct selection of an integration pattern is very important. The first integration pattern is the remote process invocation request and reply. We'll deep dive into each one of them, so I'm going to quickly go over the slide and move on to the deep dive of each integration pattern. Now let's look at the first one, that is remote process invocation request and reply. Now what happens in this case? Now Salesforce is your is the system which is making a call out to a remote system. Consider here that you have a user who's posting or making a call from the browser on, say, a Visual Force page or a VF page. It goes to the controller. From the controller, it makes a call out to the remote system. The remote system gives you the response. Salesforce, again, the controller, that is your controller, your Apex, will process that response and will show the result back onto the screen. So you can see that this happened in a single transaction where Salesforce made the call out. The response came and it showed that to the user. Now, what you need to understand here is there are additional consideration that you need to look into in this kind of integration. That is whether what is the error handling in this case. Here, Salesforce has to look after the error handling. So if the remote system is down, it has to show that to the user the remote system is down. If there is an error from the remote system, again, Salesforce needs to process that and show that to the user. There are considerations of the data volume. If you are transferring a huge number of volume across to the other system, you may be setting up for failure, right? There is again a timeline. If the remote system, say, probably takes 5 minutes to respond, you cannot have the user waiting for 5 minutes, right? These are the kind of questions that you ask when you decide whether request and reply is the right pattern for you to go or not. um, we would also look at idempotency design consideration, that if Salesforce calls a remote system, it should respond in the same way on every call. So it should not happen that once you call, it will giving you a response A, and when you call the next time, it's giving you a response B. The response at both the times should be the same, and that Again, that is again a question that you will ask when you select this pattern. Now, we have understood what the pattern is. We have understood how it works and what are the key considerations that we need to have when we select this pattern. The next thing that we know that, okay, fine, we have selected this pattern for a given integration that we have. Now, what is that we need to do within Salesforce to be able to achieve it? Now, let's look at the different solutions that can be possible for this request and reply pattern. Now, the first solution is to use enhanced external services. This is a declarative approach. Not many of us usually use this, but as a technical architect, this should be your first go-to option. There are some considerations, of course, here that the external system should be able to provide Open API 2.0 and should be able to support it. And there are some consideration about the data type as well, like how we spoke about the data volume and the data that needs to be transferred. If that is fine, you go ahead with this approach. That is using enhanced external service, which and that since because it is a declarative approach, that should be your best option. The next option that you have is to do it via a Lightning component or a Visual Force. Again, Salesforce enables you to consume any WSDL that is provided by external system. In all enterprise landscapes, you typically have a middleware that will help you with that as well. However, you will still need to consume a WSDL which is agreed with the middleware as well. Here you can perform uh, different operations like get, post, put over HTTP, and you have more options to share different data type. Again, this is the second best option. Here you will be able to process large amount um, of data that you get from your external system. And again, timing, as I said, is also a consideration of the external system's response time. The third suboptimal way to do that is trigger. However, it will still be asynchronous, because as you might already be aware from triggers, you cannot make a direct call out. It has to be always done in a future method. For that, trigger would then become a suboptimal choice in order to achieve a request reply. And once you get the response, it will be updated on the record, and then you have to find a way to show that or surface that to the user. The next is again batch apex. However, the batch could be scheduled, but the call out from the batch is synchronous. That is, you get one response and you process it. Again, this is suboptimal because it's partly asynchronous. You're doing that in a batch way, and it will be not the right way or probably the suboptimal way to approach this. Um, Now let's look at, I've completed one of the key important pattern. Is there, if there's no more question, is there any questions from anyone? Sorry, I'm not able to monitor the chat, but if there are any questions, please feel free to interrupt me.
I'll ask a question. So
Sure, go ahead.
on your suboptimal for request and reply, what
hmm
if I have a super long running process?
hmm
Um, what are ways around that to mimic asynchronous but not?
So you mean the external system is taking large amount of time to
Yeah.
respond? Um, Recently, in the last two releases, Salesforce has removed the 120-second timeout that we have for HTTP. The actual HTTP part has been separated out from that limit that we have. In that case, you could consider an LWC with a with a side component to fetch that information from a long running transaction and show it back. And that could be one consideration that you could have.
Okay. All right. Thank you.
No worries. And prior to that, the option was to do continuation API, where where you could have that call to be put into an asynchronous mode, and then whenever the response is received, you could show that response on the screen. All right, moving on to the pattern two, which is remote process invocation fire and forget. Now, typically in a situation where you have made where you don't have a user waiting for a response or looking for any response from a transaction or an update that he's made to a record or to a process that he's initiated. That's the point when you use remote process invocation fire and forget. As his name suggests, you make that or you initiate that business process and you forget about it, and you do not get a response back on your screen. Now, I have a slide that follows to show the whole process, how it works, typically looking at an event-based integration. Here, Salesforce has moved a lot towards platform events and event-based integration. If you have any process which can be triggered from and you want to follow, and timing is not a constraint for you, you could look at something like a platform event. Now, platform events are nothing but a small events that you can declaratively fire. You can have multiple subscribers who can listen to this message and carry out the actions that they need to carry out at their end. Now, here, the biggest benefit of using platform events is that there is no customization needed on Salesforce. It is easy to implement, and the scalability obviously is a big benefit. How scalability becomes a benefit? Because from as a Salesforce, as a system who's initiating the event, you only need to or you only need to create that event once. However, you can have multiple subscribers who are subscribed to your event and who can consume that for you. So, big thumbs up on declarative, big thumbs up on being scalable, and also on recovery. Now, when I say big thumbs up on recovery, because Salesforce manages an event bus for you, where all the events that are published are stored for up to 72 hours. And whoever subscriber, for example, if he's down, the system is down, they can come back and retrieve the messages which are lying on the bus, which means Salesforce doesn't need to bother if the other system was down or do any kind of error handling. All Salesforce needs to do is just create that event and forget about it. The other system, it is other system's responsibility if you are down to wake up and consume the messages which are lying on the event bus. So the recovery part is also a big thumbs up here. The next the other part is customization driven platform events. Again, this is a good option. Why is it not the best? Because you still need to customize to create a platform event. So you can create these platform events from your Apex, right? Your triggers, your classes, and then they will be again then consumed by your subscribers. So this is again scalable. The recovery is good, however, not a declarative. The first option that we had, declarative, you can generate a platform event from a flow. So that is why it is preferred to be over doing it from Apex or from a trigger. um, the other few good options to do fire and forget is to have a workflow driven outbound messages. Now, we do not recommend this going forward. However, it is something which is there on platform, so I had to put it here. But we do not recommend going with workflows. We want you to stick with flows because workflow, as we all know, is sooner or later going to get sunsetted. Hence, this is an option, but I would recommend not to take it. Um, the other suboptimal ways to do that is to have a custom UI, that is a Lightning Visual Force page or a Lightning component to be able to generate this integration. And typically, all this becomes customization. And then Salesforce doesn't need to wait for the response. All Salesforce needs to do is create or make that call out and forget about it, right? The other, again, suboptimal way is to look at a trigger which can invoke certain data changes on your other side. Uh, so again, trigger becomes suboptimal because you have to do um, your customization here. You will have to write Apex code to be able to do that. Now, Apex here would act as the stub class for the API that was provided by the other system. You will have the stub classes created here. You will use that API and make that call out. And however, you're not waiting for the response. Again, the other suboptimal is batch process. It's batch because again, it is you have to write that code. All that customization is needed to be able to achieve this. Secondly, as we all know, in batch process, you will also have certain limits of the number of callouts you can make, which also applies to a trigger, and hence it again becomes suboptimal. Uh, I have one flow where I'm talking about the platform event. I am very keen for you guys to prefer that option, and hence I've chosen to speak about platform event. So when we have two systems interacting on an event-based integration, that is the platform event, or change data capture, which also is event-based integration. The first part or the first step is for the subscriber to subscribe to to Salesforce. So how it works is basically, first the subscriber, who is the listener, would subscribe over Comet D, which is the protocol here, to the Salesforce platform event bus. Now this is a typical auth flow or authentication that the remote system should authorize to the fact that you are able to listen to Salesforce. Once the subscription or subscribe part is completed, the listener will continuously be polling to Salesforce to see if there's a message on the event bus. Now let's assume that there is a message on the event bus. There is a create and an update. Some DML operation happened. On that DML operation, you have a flow or a process to create a platform event. No, sorry about that. So you have a flow to create the platform event. Now, when that platform event gets created, that listener is continuously listening on the platform event. So I understand here that right now I'm just showing one remote system. There could be multiple such remote systems, right? Once the remote system will consume this event of the platform event bus, and it will follow it will then go to the remote system to be able to process that event at their end. Here the consideration is for just a second, for error and handling and recovery is the fact that Salesforce doesn't need to will only need to provide that on the platform bus. The remote system, if it's down, it will consume that of the event bus. Sorry about that. And no custom development is required at Salesforce side. So typically, in the case of an ESB, the ESB will consume this message of the platform event bus and post it to the remote system. Here, the remote system also has the option to call back into Salesforce to get more information, which is a very common scenario that we see. So I have covered the RPI fire and forget. Do we have any questions on this?
Any questions out there? If not, I'll ask.
Sure,
So
wonderful.
when and you probably said this earlier, but when would I use fire and forget versus request and reply?
So we will use request and reply primarily when you have a user waiting for a response. A typical example would be a payment processing, or in confirmation of an order being placed and stuff like that. Fire and forget is where you do not have a user waiting to get the response. You just make a transaction and you do not have the user is not waiting to a response.
Is there a way to use fire and forget and still get a response? Let's say I want a order created in an ERP and then maybe get the ERP's order number back to Salesforce, but the user doesn't need to see it.
Yeah, that is another way where in the fire and forget, there's a callback from the other system to update the order number that was created at ERP. Once the Salesforce has notified ERP of the order that is created, after the order is created, ERP could make a callback um, and update the order number in Salesforce, which is then probably used later for tracking or any other purpose.
Excellent. Thank you.
Sure,
I have a quick question
sure.
regarding platform event.
Mhm.
I know, as far as I know, platform event does not support MTLS. Then what is the reason behind the scenes?
So the subscription part does follow MTLS, though that's not completely mutual. Like the whole transaction, you cannot say is mutual TLS. However, we should also understand that this entire part is happening over an HTTPS. It's always um, one way secure, right? So that is a shortcoming of this part, that it doesn't have mutual TLS. However, it is still one way TLS. Does that answer your question?
Yeah, so the one we TLS is from subscriber to Salesforce, but not from Salesforce the other side, right?
That's right.
Okay, thank you.
No worries. Right. Let's move on to the third pattern, batch data synchronization, which is a very key pattern to understand. Why I say that, because we do sort of mix this with the earlier two, the fire and forget and request and reply that we saw. um, a key understanding to batch data synchronization, in my opinion, is to understand the layer of integration. Typically batch data synchronization is done when you have a data layer of integration. Now you have two different systems that you need to keep the data in sync. Now Salesforce cannot be the master of every system, right? There will be other systems who will master certain other data, like product, price book, say some other information, or certain assets which are probably created in SAP and stuff like that, right? So Salesforce cannot be the master for all kind of data, right? In this key situation, however, whatever data resides in other system, it still needs to be synced to Salesforce, because Salesforce needs that for processing. Now that's where your batch data synchronization comes in picture. Uh, it can be there are a lot of ways to do it, and we're going to speak about that now. The first and the most optimal way to do that is to use Salesforce change data capture. Now Salesforce change data capture is again event based, where every change in Salesforce gets published to the other system. Now, the key understanding here is that Salesforce in this case is the master system, because Salesforce is the one that is owning the data, and every change that happens within Salesforce, it is posting that to the other system. Um, in typical cases of keeping data in sync, you always have to understand, and I strongly recommend to ask this question to every customer or any project that you're dealing with, or when you deal with a lot of data, that who is the master of a certain data, right? So in this case, when you use change data capture, Salesforce becomes the master of that data, because whenever that data is updated or changed in Salesforce, you sync it with the downstream or the systems that use that data. Change data capture is completely declarative, and it is based on the event driven integration that we saw earlier, where every change to a record gets published on the event bus and is available for the subscribers to use it. Now, when I say any change, that also includes deletion and undeletion of records. So all the actions or all modification of data basically are available for the users to use it. Um, the next option is to go for an ETL tool, example in Informatica, which is again in this layer of synchronization happens in bulk, where Salesforce is the master of data. So ETL will pull that data from Salesforce, transform if required, and load that into the other system. Now, here, if you have a subset of data to be synced between Salesforce and the other system, your choice should be to go with ETL. Why am I saying subset? Because in change data capture, every change gets published. You do not get to select certain changes only to be synced to the other system. Um, However, in ETL, when you're using an ETL tool, you could write selective options to only pick certain records to be synced to the other system. So that's a sort of a difference between both of them. The first option is declarative. You just need to probably tick a box and set up it in the configuration of which object you want to sync. In ETL tool, however, there will be a bit of scripting that would need to be written. But the good part is you can process a lot of data, because you can use bulk API 2.0 when using an ETL tool. Uh, Now moving on, if the master is the other system, which is in this case probably when you're syncing your product information is the product inventory PIM system, which is the product master. In that case, all the information you will write a script in ETL, again on Informatica, to fetch that information from the external tool and sync it back to Salesforce. Um, the good part here is, again, when you're dealing with ETL, you can use bulk API 2.0, to be able to sync large data into Salesforce. The suboptimal way to do that is to use a remote call-in if your Salesforce I mean any other external system is your master of the data. So the external system can call in into Salesforce and update whenever a change is made. However, it can cause a lot of ongoing traffic, and as we know within our cloud platform, the number of API calls that we have is limited. So hence this becomes a suboptimal way of doing it. So whenever you have a certain system uh, which is which is holding or mastering certain data, do not choose any event-based integration from that system, to sync it to Salesforce. Do pick something which is run from an ETL, uh, or likewise a middleware, to be able to sync it back to Salesforce so that you can restrict the incoming traffic into Salesforce. Um, Now, there is another option to do that, which is not listed here, which is an external change data capture. So what we saw here, change data capture when Salesforce is the master system, and it is calling back into and it is updating the other external system. However, there is a you can also write an external change data capture. That is when external system creates an event to be consumed for Salesforce to be kept in sync. Now, batch data synchronization, I will also go through one of uh, the change data capture that we saw. So you have Salesforce will initiate the process. Will there is a change or create an update like we spoke about, that event gets published. You have a client tab which is listening, like how we had seen in the earlier fire and forget pattern. It will transform that data and update its local store. However, if there is error, it may write a certain error table and then probably sync it back for it to ensure that both the systems are in sync. Um, Typical example of keeping data in sync, we have already I've spoken that a few times, which is the product and pricing, which is a very common one to keep your systems in sync. The other is when Salesforce becomes is where your customers or your consumers are registering. So Salesforce becomes the master of account and contact, and hence it becomes Salesforce's responsibility to keep it in sync with other SAP or downstream systems. That's the a very common example that we usually see of few places where data needs to be kept in sync between the different systems. Um, okay, so we have looked at the third pattern as well. Any questions up till now on this one? All right, no questions. I'll move to the fourth one, which is remote call-in. So we've all heard of. I mean, whatever we have heard till now mostly has been where Salesforce is calling the other system, right? That's an outbound call. And now, at the same time, we also need to be mindful that there will be certain processes where other system needs to call into Salesforce. That becomes an inbound call. So for remote call-in, what we have within Salesforce are certain options to for remote systems to call Salesforce using REST API, or also sometimes be able to generate an event and be able to call Salesforce. Even that is possible. So there is you typically have a client using has which authenticates to Salesforce using Salesforce REST API. Once the authentication is completed, if at client side there is an error, there is an error event that occurred and it wants to call into Salesforce, it can also create an event and post it on the onto Salesforce. So the Salesforce event can also be generated from an other external system via REST API, because the events are also available as REST API to be submitted from an external system. This could be an event. This could also be just a call out, first authenticating and then making a call out. And then if it's an event, then it gets published on the Salesforce event bus. And then sales on a certain event, you can also write triggers for for whenever an event is generated, certain process to be completed. So this way, or the alternate is if you do not use event-based integration here, the alternate is that the remote system will call first authenticate itself, make the call out to Salesforce, the processing will be completed and a response will be provided back to the external system. Now, there are different ways to do that. Uh, the best way to do that is Salesforce allows you to use SOAP and REST API. It provides out of the box. Salesforce provides SOAP and REST API for external systems to consume and to be able to make a call out. There are different events like to query data, to create, update, or delete data. All these call outs that are or remote call-ins that are made, they are all secure because you need to first have a login. You first need to make a login call, have a session, and then only you can provide or make that call. You can also have high number of bulk data is also something that you can use using bulk API. There are standard whistles available, enterprise and partner, which can be used to connect to the system. And also event-based architecture is also possible. For how I showed you that all platform events which are available or which you create on Salesforce, they can also be consumed using REST API. So there's also a way to do that. This is the best way to do that, and it's declarative. The external system would obviously have to parse the WSDL file, have client stub, and be able to make that call. The suboptimal ways is to have Salesforce host custom REST service, so that becomes an Apex class, which has REST resources mapped to certain URIs, which you share with your customer, and then sorry, you share with your external system as part of your contract agreement, and then they can make that call out to you. However, the point here is that if there is a change on your side, if the data model is changed or you've added a new field or you want to add a new element in your contract, you will have to change your side at your side, that is a Salesforce side, the custom API that you have added, and then obviously the external system would also have to make a change. However, if you're using the SOAP and REST API, you don't need to make any change from your side because that's a standard API that is available. However, the external system would have to make certain changes to be able to pass more information or be able to query more information from Salesforce. So the best way to use is Salesforce REST and SOAP API with every API, every version of Salesforce. You if you you can have or use still be able to use the previous data model that you have. There is no need to upgrade if there is a change in the data model here. All right. So we've seen remote call-in. Other key call out that I want to make about remote call-in is that whenever a system is calling into Salesforce, that is an inbound call, all that gets called uses your API limit. Now, when you are making an outbound call, those don't use your API limit, but every inbound call uses your API limit. So be very, very careful of when you are doing a remote call-in to ensure you're doing that API calculation at your side and your system does support or has the has the number of API calls available for it to be used. All right. So we've seen the fourth pattern. Checking with the audience if you have any questions.
So I failed miserably at monitoring the questions. We had one on batch data synchronization.
Sure, no worries.
Um, if we can skip back just for a second on this. And the
Yeah.
question was, how is platform event different from change data capture?
Under the line, it is the same. Every change does create a platform event. Um, so it is all event based architecture only. Uh, but in platform event, when an event you have to identify when an event is being generated, and then create the event to be sent out. However, in change data capture, Salesforce takes care of to identify the change and to then form the event JSON and send it across to the other system. But underlying concepts are same. Architecture is same. It's just the way you do it is a little different. I hope I answered the question.
Thank you.
I have a quick question, sorry,
Sure.
regarding the CDC. So
Mhm.
underlying CDC and the PE actually the same,
Mhm.
but CDC right now is in the actually in the batch synchronization category. Then because of the volume.
Yes, and the concept, right? You are trying to sync data between two systems, right? You are not generating the platform event for some business process or anything. Change data capture is you're trying to keep two systems in synchronization. Hence, it becomes batch data synchronization. It's a data layer of integration. Does that?
Okay, got you. Thank you.
No worries. Right. Any questions on remote calling? I guess. All right. So let's move on to the final and, in my opinion, the most underrated integration pattern ever. That is data virtualization. So initially, I spoke about three type of integrations, right? Data layer of integration, process layer, and third is virtualization. So in this, as an architect, it becomes your key responsibility to understand what each system does, right? Each system should be used for the reason that it is most famous for, right? You cannot have say a cloud system to and have and be able to use um, all its resources for only for a single process. You have to divide its resources for different type of capability. So for example, if in Salesforce, if you want to generate or you want to create a fancy looking say barcode, right? Salesforce is not the right system to be able to do that kind of an image processing, right? You may have certain tools which you can add on to the platform and be able to do that, but just trying but when it comes to CRM capability or say running analytics or few other capability, then Salesforce is the best choice, right? However, similarly in your enterprise landscape, it becomes extremely important to understand where and what is the capability of each system and how should I use it in the best way. Um, Similarly, on the same lines, uh, on a data layer where you cannot bring all your data onto Salesforce, where your data is also charged, right? Volume calculation of volume of data on your Salesforce platform is a key responsibility of a technical architect to understand how much data will be required for any system or a process that you're trying to bring on your platform, and hence becomes your responsibility to also understand what is data virtualization. So data virtualization is a concept where data is not residing on your platform. It is residing or it is mastered somewhere else. And you are only bringing it when you need it. You don't bring the data and keep it on platform. You only bring it when it is required. And hence you're virtualizing it. The best way to do data virtualization is to use Salesforce Connect, which is the concept of external object. So you have, say, other system which probably the example that I gave when I started the session was of the order placement, right? We saw that the order was placed and it was fulfilled. However, the shipment status or the fulfillment status is with ERP. Now, you will not bring that fulfillment order on your platform to show it to the user. What you will do is when the user is requesting for that status, you simply show that status, right? You do not bring or keep the data in sync between two systems because fulfillment was supposed to be done by ERP, and ERP is known to do that, right? So in that is the case where you use the concept of external object, where you can bring in the Salesforce external the fulfillment order information on platform. Here the concept is that the data doesn't come on platform. It is still mastered and stored on the other system, the external system, which is ERP in this case. However, there is an OData layer of integration between them. You can use OData 2.0 or 4.0 by setting that up. Um, and then you can simply see that data on Salesforce, just like any other normal record, right? So Salesforce Connect is the product that you buy, where you get certain external objects to be able to connect to, and a system to connect to. The only underlying requirement is that your external system should also be able to uh, should have an OData adapter, or should be able is compatible with OData. However, in all enterprise landscape, you typically have a capability of MuleSoft or its like alike systems, and those can give you the OData connector capability here. uh, it is again declarative. You do not need to write any code to be able to achieve this. All can be done via Salesforce setup. However, there are some limitations in the number of OData callouts that you can make. But giving you the example of the order status, right? You may not have a lot of users looking for order status all the time. So such cases, you may choose your Salesforce Connect, an external object, to surface that data in Salesforce. The suboptimal way here would be to have a lightning component or a visual force page, which or an LWC basically, to make that call out to the external system, fetch that information, parse, and show it on the UI. Now this is again a synchronous connection. External object is, by the way, also is synchronous. It'll show you right on the record itself. Um, However, because it is customization, we've named this as a suboptimal way of doing it. All right, so I have covered these two options that you have for data virtualization. External object being the best way, however, making having any customization being the suboptimal way to do that. Do we have any questions on the fifth pattern, that is data virtualization?
So you beat me to it on the on answering my question, which is what happens if you don't have OData. Um, is Canvas or Mashup still an option for virtualizing data?
Yes, Canvas could also be an option for virtualization. However, that comes in the UI layer. But yes, Canvas could also be another option to do that.
And one final one, which you can throw a rock at me if you want. Um, I'm leveraging OData to present um, the external data, virtualize it.
Mhm.
So I have my external object. How do I secure the records and external objects? What are some of the ways
So
I may have to do?
Uh, there are there are a few considerations here when you talk about security. I would break this part into two parts. An external object also is over HTTPS, so that is one way secure, and that takes care of the network layer of security. The other part of the security element is the data security, right? Now, on external object, unfortunately, you do not have row level data. You cannot have sharing rules and have a row level of security. The Probably the way to get around with that is to use the capability that we have. I'm forgetting the name. Restriction rules. So you can write restriction rules to level of securing the data that the user sees, because it doesn't support row level security. That's the other way. Uh, like for row level security, if you can try with restriction rule, or there is an option to set up custom headers where you can pass a certain user's credential or user's identification, with an assumption that the external system or the fulfillment system will only give you those records which the person or the ID that you have passed um, is able to see, right? So that's few ways that you can come around with the data layer of security. I hope I
Awesome.
answered your question.
No, that was great. Awesome.
Good.
We did get another question coming in via chat.
Hmm.
Um, so summer 23 feature, which is in beta, and I
Hmm.
don't know if we're ready to answer beta unless we've played with it, because I certainly haven't played with this one yet.
Sure.
Um, so send Salesforce data to an external server without TTP callout, and they want to know what pattern is this. To me, that sounds like some type of callout. It'd probably be a fire and forget, but it could be batch data synchronization. I haven't played with it.
Yes, I wouldn't. All we are saying in summer 23, you're saying that is very recent. You
Yeah,
have
it's
uh,
The new release notes.
Yeah, yeah. You really know. That's right. So, could you repeat that line again? Sorry, Walter, for me.
That's all right. So it came in from is it Kothai? Hopefully, I didn't slaughter your name too much. The Summer 23 feature, which is send Salesforce data to an external server
Hmm.
without code via HTTP callout. What pattern is this? It's, to me, that's
HTTP call out.
yeah,
Yeah,
That
I'd like
could be
to,
fire and forget and request and reply both. Right?
yeah.
I
yeah,
mean,
I'd like to
either,
elaborate.
either.
I would like to
Yeah.
elaborate on that.
Sure.
That's
Sure.
from flows. So now they're saying in flows, you can send out an HTTP call out and get data. You can send data to an external system.
Right.
So
Right.
I was wondering if you can, how it's still in beta. I haven't tried it, but I was wondering what kind of pattern it is. Like, is it like fire and forget, or can you get a response back and do something in the flow with it and things like that? And you
Yeah.
haven't
So
played with.
if it's in a triggered flow, and once again, this is beta,
Yeah.
but if you look at the pattern itself and what's happening behind the scenes, a flow is being triggered by some activity. That and within the flow, we're saying we want to send this set of data out to another system. That's going to be most likely a fire and forget. Um,
Yeah.
Otherwise, there's other ways to handle that.
Right. That's right. You nailed that one, Walter.
Thank you.
Yeah. All right. So, quick decision matrix of whatever we've heard till now. Um, Few things that you will ask yourself before you decide the pattern is first, the first key question that we saw earlier, um, is what is the direction of your integration, right? Is Salesforce calling the external system? That is an outbound call. Once that is established, you then identify what layer are you integrating with. Is it a process layer of integration? Is it a data layer of integration, or are you virtualizing data? Like the data is residing in some other system and only you need to only bring it on certain clicks or certain events, right? uh, you After you have done that, you ask the next question to your customer or to your team, or that what is the timing of your request? Is it synchronous or asynchronous? Once you have established these three key questions, you have your answer to your pattern. And once you know the pattern, then we've already seen how you implement it. So I've just broken down whatever we saw in the last 50-55 minutes into this small decision matrix that we have. So if you have a process layer of integration, very good example, payment integration, where the user is waiting for the response, your choice of pattern is request and reply. However, if your your user is not waiting for a response, and he's okay to get an email about confirming whether the payment was done or not, that becomes your fire and forget, right? The next is, if you it's a data layer of integration. Now, if it's a data layer of integration, we've seen, but and it is very critical information, right? And you need to have it synchronous. That is, you need to confirm to the user that his, say, phone number was updated in some other system or not. In that case, you will keep that as a request and reply pattern. However, if it's a data layer of integration, and it doesn't need to be confirmed back to the user, then it becomes an asynchronous. And so your option of the pattern is UI update based on data changes. This is a very less used pattern. That's why I probably didn't cover in the key five, considering the timing. But that's the other way to uh, update asynchronously any data changes. The last one is if the data is residing in some other system and you do not want to bring it on platform, you virtualize that data. In that case, all virtual data integrations are typically synchronous, um, and that in that case you will select the pattern as data virtualization. The next part, or the next part of the decision matrix is where your if your source or your direction of integration is from external system to Salesforce, that is inbound integration, that a call is coming into Salesforce. In that case, you if it's a process layer of integration, if it's synchronous, The option is remote call-in. Typically, in all inbound calls, the options are only remote call-in. However, if you have um, a data layer of integration when a system is calling you in, and you have an asynchronous, that is, you don't care, it can be done later as well from a timing perspective, then you go with a batch data synchronization. Now, in this pattern, that the last one that we saw, the batch data synchronization, the external system is the master of the data, and Salesforce needs to use it, right? And hence, this is the other option or the other way uh, to achieve this. That is batch data synchronization. Now, whatever we have discussed till now, I have shown that as a decision matrix. All of this is also available in Salesforce Help. If you review the integration architecture trailhead, you will have this PDF talking about all the patterns and in detail, further more detail, and similar decision matrix also available on that PDF. I've been inspired from there, and I'm talking to you about it. However, uh, just keep that in mind. The choice of your pattern depends on three key identifying three key things: a, the direction of integration; b, what is the layer of integration; and third thing, that is, what is your timing of your integration. Obviously, there are few other considerations, the additional consideration that we saw earlier, which is the volume of the security, the idempotency, and few other things, and the state management that you need to be also careful about. But these three will give you the right pattern to work with, and then comes your the next step, that is how to implement that in Salesforce. Uh, with that, I have concluded uh, whatever I had planned. If you have any questions, I'm happy to answer them now.
All right. Well, thank you. We are at time, but I will leave the call open a little bit. If anybody has a question, you can take yourself off mute. And if not, thank you very much for presenting and sharing your knowledge and experience with integrations.
Thank you. Thank you so much, Walter. Thank you everybody who's joined the call. Wish you a
All
nice
right.
day.
Have a great afternoon and evening, and the rest of the evening for you, Poonam. Thank you.
Thank you. Thank you. Bye bye.
Many thanks. Great session.
Thank you. Glad it helped you guys. Thanks. Bye bye.